Hello students, welcome to first session of graph theory. This is the first session of unit 1. In this session we study about definition of graphs, types of graphs and some examples. This unit contains graphs, isomorphism and subgraphs, walk, path and circuits, Euler and Hamiltonian graphs, trees, distance and center in a tree, binary and spanning trees, fundamental circuits, learning objectives and outcomes. The objective and outcome of this unit is to study about basics of graphs, isomorphism of graphs, Euler and Hamiltonian graphs, subgraphs, trees, spanning trees and fundamental circuits. Definition: a graph G equal to pair VE consists of a set of objects V equal to set V1, V2, etc. called vertices and another set E equal to set E1, E2, etc. whose elements are called edges, such that each edge EK is identified with an unordered pair VI, Vj of vertices. The vertices Vi, Vj associated with edge Ek are called the end vertices of Ek. The definition of self-loop: an edge having the same vertex as both its end vertices is called a self-loop or simply a loop. Now definition of parallel edges: two or more edges having the same pair of end vertices is called parallel edges. Now an example of a graph with 5 vertices and 7 edges. The vertices are V1, V2, V3, V4 and V5. So vertex set V equal to the set V1, V2, V3, V4, V5. The 7 edges are E1, E2, E3, E4, E5, E6, E7. So the edge set E is equal to the set E1, E2, E3, E4, E5, E6, E7. And here E1 is a self-loop because its end vertices V2 and V2 itself. So same end vertex for V1. So it is a self-loop. Now consider V4 and V5. V4 and V5 has the same end vertices V1 and V3. So they are parallel edges. So here edges E4 and E5 are parallel edges. Note that in drawing a graph, the edges can be drawn straight or curved, long or short. Important is the incident between the edges and vertices. Now see the example. Here there are two graphs A and B. Here the vertex 1 is incident with vertices 2 and 4. Similarly here also vertex 1 is incident with the two vertices 2 and 4. So here the edge 1, 4 is a straight line. Here the edge 1, 4 is a curve. But these two graphs are same because the incident between the edges and vertices is the same in both cases. Now we study about simple graphs. Definition: a graph that has neither self-loops nor parallel edges is called a simple graph. Now consider a graph. This graph has neither parallel edges nor a self-loop. So this is an example of a simple graph. Now we have a problem to draw simple graphs of 1, 2, 3 and 4 vertices. Solution: here is a graph with one vertex and this is a graph with two vertices. This is a graph with three vertices and this is a graph with four vertices. These are all simple graphs because they have no self-loops and no parallel edges. Now using 3 or 4 vertices we can draw different simple graphs also depending on the number of edges. So the graphs are not unique. Also, simple graphs are not unique. Now consider these two edges. These two edges seem to intersect at this point, but this point does not represent a vertex. Here we note that in a diagram of a graph, sometimes two edges may seem to intersect at a point that does not represent a vertex. For example, edges E and F in the graph below intersect at a point that does not represent a vertex. Now see the graph. Edge E is this and edge F is this. They seem to be intersect at this point, but this point is not a vertex. Now, finite and infinite graphs, the definition. A graph with a finite number of vertices as well as a finite number of edges is called a finite graph. Otherwise, it is called an infinite graph. So, example of a finite graph. This is a finite graph because it contains 4 vertices and 5 edges. And we have a portion of an infinite graph. So here vertices are infinite and edges are also infinite. Reference is Graph Theory with Application to Engineering and Computer Science by Narasingh Deo, Prentice Hall of India Private Limited, New Delhi, 1995. Thank you for listening and watching this video. Thank you all.